Webinar with Inspired Flight and Sentera. High accuracy mapping workflows with the IF800 and Sentera 65R RTK and PPK. And before we get started, a few friendly reminders. Questions will be entertained at the live Q&A after the presentation, so please use the Q&A menu option at the bottom of your screen to submit your questions. This webinar will be recorded and available online after the live event, so please feel free to share this content with your network. After the webinar ends, you'll be presented a brief survey, so please complete this and provide your honest feedback. It really helps us improve. And today we're joined by Adam Bilmes. He is the co-founder and business development leader with Inspired Flight Technologies, where he works with commercial and government customers to align mission requirements with reliable NDAA-compliant UAS solutions. Adam's focus is on real-world operations, helping teams evaluate platforms, payloads, and workflows to deploy drone solutions with confidence. And we're also joined by Matt Skelton. He is the sensor integration lead and product marketing manager with Sentera. And he is an aerospace engineer who has been working in the precision agriculture and UAV space for the last 10 years. Matt earned his aerospace engineering and mechanics degree from the University of Minnesota, where he began his UAV career in the university's UAV research laboratory. He continued his journey at Sentera, working on its PHX fixed-wing drone platform, starting as an intern and advancing to product manager. So without further ado, guys, take it away.
Howdy.
Thanks for that intro. It's good to speak to you all. Nothing like Wednesday afternoon talking advanced UAS mapping workflows. So again, thanks for the introduction. My name's Adam Bilmes, one of the co-founders of Inspired Flight. Just a quick 30-second brief on Inspired Flight, if you're not familiar with who we are. We got our start in 2017, originally as a components manufacturer, quickly became a complete commercially focused first UAS manufacturer. Fast forwarding today, our flagship products are the IF800 Tomcat, as you see here, as well as our larger IF1200 system, and just been really valuing the partnership, certainly with Sentera, which we're going to get into today, but also just really want to shout out DroneNerds for the incredible partnership, and thank you all again for putting this webinar together. And Matt, if you wanted to say a few words before we dig in.
Hey, everybody. I'm Matt Skelton. So Sentera is a St. Paul, Minnesota-based company recently acquired by John Deere, although I guess recent isn't, it's been almost a year. But we specialize in making sensors for enterprise level UAS that are all NDAA compliant. We wanted to make sensors that provided high quality and efficient solutions for all of these. We've spent a lot of time out in the fields, mapping, doing all that sort of stuff. Because we really started in precision agriculture and realized that our sensors had much more application than that. But being out there, it's a long day. You're flying big flights, and so we wanted to make sure that we could be out there efficiently because we didn't want to just be burning cash, or anybody would be burning cash out flying their UAV. It's all about efficiency, and so we think that goes all the way down to the data capture, right? So, anyways, back to you, Adam.
Yeah. So really kind of just to frame this conversation, what is our goals in kind of sharing with you guys today? Our goal isn't really to educate you on like what RTK is, what PPK is. There's a little bit of an assumption that the majority of you are coming from a mapping, surveying, GIS, research type background. So what we really want to focus on today is like, what are the advantages of the workflows and the accuracy advantages that the IF800 and Sentera combined RTK system really brings. Like some of the things that we're going to touch on today, as you can see here on the far right, this module for RTK PPK that sticks on the top of the aircraft. Why is that needed? And why does that potentially provide some advantages over other systems where you might say RTK PPK might be kind of a built-in feature? Why am I being asked to purchase and install another piece of hardware? So those are some of the things we're really going to work to dig in today to try to kind of just provide examples of what our data processing workflows look like, the openness of the ecosystem, and how this can fit into a wide variety of mapping, research, surveying, remote sensing applications. then, of course, talk a little bit about why the IF800 is a good aircraft to kind of enable the collection of that data, as Matt kind of pretty eloquently said. That's all. That's all we're out to get, right? At the end of the day, this is about the data and the accuracy of that data and the efficiency in which we can collect that. The drone is simply a tool to go and achieve that. So again, yeah, why the IF800 for mapping? Of course, I'm biased, but bluntly, it's really what it was designed for. About 40% of the IF800 customers' use cases out in the wild are a strictly mapping use case, whether that is photogrammetry or remote sensing with multispectral cameras. Then there's another, I'd say, 30 to 40% of our business that is using a combination of mapping as well as LiDAR technologies. And one of the real great advantages of the IF800 is the ability to swap between payloads such as a multispectral sensor, a photogrammetry sensor, and even a LiDAR payload toollessly in the field. So the IF800's been on the market for a little over a year, class leading for an electric multicopter in its weight class, 54-minute max flight time with no payload. Somewhat useless metric, but up there to compare to apples. With the 65R camera that we're really going to be focusing on today, all the coverage information we're going to be providing is based off a usable flight time of about 40 minutes with that payload. Matt will kind of allude to it, but one of the advantages of this camera is how fast it can fire off photos. And to do that, it requires a drone that can fly fast along with it. And at 6.63 kilograms of payload capacity, a number of LiDAR capabilities and other heavier payloads that can be used in conjunction with the Sentera 65R. And one thing I'll mention here in the left corner, the IF800, the IF1200, all products kind of being talked about today from Sentera and Inspired Flight. Whatever flavor of compliance you might be looking for at this point in the drone industry, whether that's full blue UAS if you're operating on Department of Defense, Department of War property, or a member of one of those organizations, whether you're using federal grant money with requirements to purchase NDA compliant systems, or if you've simply been asked to move forward with USA built equipment. We check all those boxes for compliance. The focus of today is, of course, on the product and the data, but do want to kind of mention that everything we're talking about today does meet those requirements. So these are the four sensors that are compatible with certainly with the Inspired Flight aircraft, as well as with the RTK PPK system today. The three cameras on the right are a flavor of a multispectral camera available from Sentera and from Inspired Flight and from DroneNerds, of course. Matt will provide a little bit more specifics on them, but the 6X multispectral in the middle, kind of the standard multispectral camera. And then really the other one that we focus on is the 6X Thermal Pro, which replaces the blue filter on the multispectral camera with the 640-512 radiometric FLIR boson core. So that's on the kind of the remote sensing multispectral side. And really where we're going to focus today is with the Sentera 65R. Fantastic camera, lightweight, 65 megapixel global shutter. And kind of turn it over to Matt and get into the technical details a little bit further.
Awesome. So this is a great segue from talking about the sensors, the compatibility, and their performance. So as Adam mentioned earlier, and as I was mentioning as well, is this is the question we probably get asked the most, and it's always, how much can you map in one flight? And the answer really is, for everybody, it depends. So really what drives this is your GSD requirement, which drives your altitude, your overlap requirement, and your flight speed and all of that sort of stuff. So the good news is that our sensors, Sentera sensors, fire so quickly. So with 65R, you can capture 3 images a second. And with any of the 6X cameras, you can capture 5 images a second. So you're never going to be limited by flight speed, at least not in regimes in which you can legally fly under Part 107. So really, it's altitude and overlap, and your altitude's driven by your GSD. So we picked a couple examples that we thought were indicative of normal flight patterns. So over on the left here, we have where we went out and did some mapping of some baby lettuce out in California. And so with this one, we're a 400-foot altitude, which with the 65R, which gives you roughly a 1.4 centimeter GSD. And that's, you're going to fly for 40 minutes of flight time, and we're going to assume 75% overlap. And so this gives you about 140 acres in one flight. which is super comprehensive, right? 140 acres of 1.4 centimeter GSD stitchable imagery. And that's just really awesome. And I think we're probably flying at 20 to 25 miles an hour right there. But this other really cool example that we have here over on the right, this was just a blog post that Inspired Flight put out with Alabama Department of Transportation, which is really cool. So they use 65R and IF800 to go inspect a runway. So obviously, everyone here has flown drones. We know that airports are difficult to operate drones around. So when you are going to operate a drone around, they shut down the runways, and you really want to minimize that time because it's just not useful for any of the air traffic to be shut down from these strips. So part of their thing here was like, how do we minimize our downtime on the strip to map it, and then also get the GSD that we need? So in this case, they wanted sub quarter-inch GSD, which means with 65R, you're flying between 100 and 125 feet AGL. And to map this really quickly, since the camera is such a fast capture rate, we decided, why don't we fly at 31 miles an hour? Let's just get this done. And the imagery came out really beautifully. I think the Alabama guys were sort of skeptical on whether or not the sensor could do it. And, the quote that came back from them was, "We are amazed with how clear and crisp this imagery is." And you can see they're doing, awesome amounts of crack and fault detection on the sample image there. So, these are cracks on, they're probably an inch or less wide on these runways. And so they captured the whole thing and were able to be like, great, now we can go out and deploy our repairs plans. Okay, RTK PPK module features. All right, so as Adam was talking about, why is this a separate piece of hardware? We're going to talk about the features first, and this is going to tie into where we're going to why this is a separate piece of hardware. So again, we're not reinventing the wheel here. So RTK, PPK, 1 to 3 centimeter of positioning accuracy. That's that's what RTK is. We've got dual frequency GNSS, so we support L1 and L2 multi-constellation support. So this is your, GPS, BIDO, Galileo, GLONASS, all of that. So you're not missing out on any channels on anything yet in the currently available market and satellite frequencies and bands that are being actively used. Another really cool thing that's a feature here is that we offer flexible correction sources. So, it's not just NTRP through the hand controller, or it's not just NTRP through a laptop that's bridged to your hand controller, or it's not a proprietary base station. We wanted to make sure that this module was something that you could work with the equipment you already had or the workflows you already use to the best of our ability. So we support the NTRP networks, we support local base stations, we support all sorts of ways to get the corrections up to the aircraft or up to the module. Direct GNSS timing. So this is pulse per second. So we're going to dive a little bit deeper into this in the next slide, but this is a really important piece of what helps bring the precision of this module above where everyone else is sort of sitting. So this gives us the ability to synchronize using pulse per second timing. And that's important for the geotags. And then lastly here, NDAA compliance. So these are all, we designed these. These are designed in Minnesota. They're programmed in Minnesota. They're assembled in Minnesota. They're tested in Minnesota. Everything is done here stateside. So why does the direct GNSS timing matter? So we'll start this discussion here, and it's going to flow over into the next slide. But long story short, we've got a bunch of different hardware components that are sitting there talking to each other inside a typical UAS system, right? You've got GPS receivers. You've got an autopilot. You have all these other sensors, and then you've got the actual camera in there. And so when the camera, the autopilot's talking to the GPS, and it says, okay, now I'm here, I'm going to take a picture. So it gets that information from the GPS. Autopilot tells the camera to take a picture. Camera takes the picture, then it has to get that GPS information from the autopilot, which also has to get it from the GPS. And so long story short, when you're flying at 20 miles an hour and you've got these tens of milliseconds of delay in there, you can start to introduce time delays between when you actually took that picture and when the camera got the GPS information from the drone. So how do you fix this? You fix this by using PPS synchronization. So PPS is pulse per second. It's a signal generated by the actual GNSS, the GPS hardware itself, and it talks directly to the camera. Essentially what this does is it just creates a very steady signal, and what this allows us to do is the GPS knows when it sent that signal, the camera knows when it got the signal, and so then it's able to take, hey, we had all this we had all this timing offset. We can actually use the PPS signal to go back and synchronize the geolocation and the imagery data together so that we know exactly where that picture was taken with the highest degree of accuracy. So this takes anything that was, tens of milliseconds and brings them into the nanosecond realm of delay, which is, an order of magnitude. It's much faster, much more accurate. Um, so that's like the big thing. This is why PPS synchronization is very important and it's not broadly available across many other systems. So that's why we decided we wanted it in our system. We wanted to be able to talk directly to the GPS hardware so we could have this feature and functionality that exists. The other part of this is that to have the PPK workflows, we have to have access to these raw GPS measurements that come from the GPS receiver itself. These are not messages that are broadly available through Mavlink messages in any sort of way. And so to also enable the PPK messages here, we decided we're going to handle it all on ourselves with our hardware and our sensor. When you see this on other systems, they're logging that GPS or that GNSS data elsewhere and then combining it back with the sensor data later. And so because it's not all synchronized at the same time, again, you have reduced accuracy and efficacy of what you're trying to do. When we are doing it with our hardware, it's all happening at the exact same time, again, with that PPS synchronization. And so the third part here on why we decided extra hardware was because we wanted to support all these different corrections sources. Say you have a base station you already own and you don't want to buy a new one, or maybe you're going to go out somewhere really remote where Ntrip isn't going to be available because there's no cellular or LTE services out there. We didn't want you to have to make you buy a proprietary base station. We wanted you to be able to use the equipment you had. So to do this, we needed a way to get that corrections information up to the drone. So sometimes it's not always super easy to integrate a base station into a hand controller and forward it up through the data link. So we decided, why don't we take a really reliable 915 megahertz radio that we know has a very long link range and is very reliable and low power, and let's put that inside the module. So actually what you see on top of the drone there is not only the GPS receiver, but there's a radio inside of there as well. And so this allows you to have RTK corrections and not worry about, hey, like a digital data link could drop out or something like that. No, it's an analog radio. You're able to plug this thing into base stations, laptops, anything that will send you RTCM3 messages out a USB port. You can plug this radio in, and now we have a way of getting all these the RTK corrections up to the drone, independent of the rest of the drone system, which makes it really flexible and really easy and really reliable to use.
Yeah, I think that was one of the most important parts of just our co-development of this product, especially for inspired flights customers, particularly in the more industrial world, less so the research environment. Our civil engineering customers or construction environments, they're typically very tied into whether they're a Trimble shop, a Top Gun shop, right? Where they are in the country. If we're talking about the US, do we have access to Intrip? So being able to say yes to all those different kind of ecosystems, to be able to just go and fit into an existing ecosystem without requiring a much larger enterprise's standard operating procedures to change, we see as just a massive advantage.
All right, what else did we do that was really cool in all of this? So we talked about Ntrip, and this is a great flavor of RTK in all of this. But you see a lot of times in many of these other systems that exist out there today, you're taking, a laptop and you're bridging it to your hand controller, and your hand controller is then bridging it up to the aircraft. And so the good folks at IF800 and Sentera decided, no, let's not do that. Let's get an Ntrip client built into that flight control software, and let's put it inside the hand controller and make it super easy peasy like that, or that way. So you can hook your hotspot up to your hand controller, or you can put a SIM card in your GS1, and you can just load in all your Ntrip profiles that you want. So that's what you're seeing here. In the middle of the screen is you tap that little green T with the, we'll call them like the signals coming off of it. And it's going to bring up this Ntrip menu. So it's really cool here, right? You've got your Ntrip server address, your port, your mount points, and you see right next to the mount points, there's a little magnifying glass. If you tap on that, it will actually just pull up all the available mount points from that Ntrip server address. And then you can select which one you'd like. Then you put in your username and password, and you're pretty much ready to go. And so that's just like part one of that. What's really cool is there's also the ability to make presets and load multiple profiles in here. So say you're going to move state to state and you're going to switch corrections networks, or maybe you're going to move, tens of kilometers away and you're like, I actually want to use this mount point, or maybe you need a different mount point for a different reference data and what have you, right? Instead of having to punch all of this in at the same time, you can just keep making copies of these presets and change just the bits and pieces that you need, and then they're just always available for your hand controller. Um, but what we also wanted to do on top of what we thought, okay, if we can make it this easy on the hand controller for the end trip, can we make it that easy to understand what the camera is doing? And the answer was yes, we could. So we built in a camera icon or a Sentera camera indicator up in the upper right hand corner. So when you connect a Sentera camera to Inspired Ground Control, it knows it's talking to a Sentera camera, and you're going to get this little icon in the upper right hand corner. Green tells you it's ready. There's a couple other states in there, but then it's also going to display what level of RTK fix you have in there. So you can see on the screen there, I've got an RTK float fix. I was inside. So that's all we were going to get when I was doing it. It's very cold here in the winter in Minnesota, so I didn't want to go outside for a single screenshot. Come for me. You can also tap on the icon, and then it's going to show you the state of the camera, your photo count if you've missed any photos, and then your GPS type. But then also at the very bottom there, it shows you your session. And on a Sentera camera, this is the folder where all your data is stored based on when that camera was decided it was ready. So that's really useful if you're out in the field flying a bunch and you're like, hey, I don't want to, where's all my data? I don't need to offload it every time. You could just write this down and be like, all right, field X that I flew is this session folder. And then you'd know for later when you go to do all your data offload. Anything I missed there, Adam?
I think we're good. Talk a little bit about PPK workflows.
PPK workflows. All right, sweet. So PPK workflows and base stations. So again, we try to make this as flexible as possible. So what's really cool is that not only is this an RTK unit, which is what we've talked about, but this is also a PPK unit. And this is a great time to note that anytime you're operating this in an RTK mode, you are still also always logging the PPK data. So if something were to happen, like maybe your correction source like goes out on you, or you lose like maybe your hotspot dies or something, right? You will always have that PPK data backup where you could go back and actually still post process your data if something were to happen with the RTK data. Um, but PPK offers a really awesome workflow. I've actually almost moved entirely to PPK myself just because I find it to be a bit easier. So you're not dependent on like a live link, you're not dependent on cellular activity. You go out there and you just fly. So if you're working with the base station, you set your base station up, you make sure that's good to go, and it starts logging all of its RINEX data that it's going to share with you later. Or you can get this information from a VRS or a corrections network. Oftentimes they host servers where after the hour flips or 2 hours after the hour flips, you can go download all of the observation data and RINEX data you need from that. But this gives you the ability to just go out, fly, collect the data, and then when you're done, you come back in, you offload your data from your sensor. You use a processing software to combine your data that came from the camera, which is your trigger file or your timestamp file, your rover file with all your imagery, and then you take your base station data or VRS data, you combine that all together. And oftentimes this is actually a little bit more accurate than RTK just because they can correct for atmospheric conditions and other such things. And they're not trying to do it live in flight. And so you get this really awesome, very accurate solution. But this is really good when you're out in the middle of nowhere. You have no cell phone or cell coverage. You can't use Ntrip. And even if you can, it's always great to have a backup. So particularly what I often do is I run an MLib base station and I'm running RTK in it, but I'm also logging PPK data. And I have that always as a backup. So I'm always going to have high accuracy data no matter what happens. So base station compatibility, this was the thing we talked about. So right now we have verified MLIT RS2, RS3s, Trimble R980. And we trying to support absolutely as many base stations as we can. We're working through the TopCon integration and all of that, or verification, but pretty much any base station that will offer you a USB out with an RTCM3 stream, we can support for RTK, and then anything that will just log RINEX data, we can support in a base station and a PPK workflow. So let's look a little bit now at the RTK workflow and planning a mission here. So first thing you're going to do is you're going to connect your hand controller to a correction source, so that Ntrip client that we talked about there. Or you're going to set up your base station and your ground radio that comes with the kit, where you can just plug that into your base station. Then you're going to configure your mapping mission. So this is, drawing your box. This is where I'm going to survey. We're going to set our altitude. We're going to set our overlap, all that good stuff. We're going to send the mission to the drone. We're going to make sure that that green camera indicator up in the right-hand corner is green and it says RTK fixed, which would be your integer level fix, right? Your centimeter level accuracy. Then you're really you're gonna go back to your fly screen on your hand controller in IGC. You're gonna hit start mission. You're gonna slide the little slider, and that thing's gonna take off, and it's gonna just go start doing its thing. Not a lot of extra setup outside of any of what we just described or what we've already talked through. So if you're flying with RTK, you'll get your RTK imagery tagged at the time of captures. This is also another thing that's unique to Sentera cameras, is that when you are operating a Sentera camera in an integration like we have with Inspired Flight, we geotag at the time of capture. There's no going back and adding geotags like you maybe see with some Sony operations or what have you. It's all ready to go. So if you were flying RTK, you could literally take those images straight off the camera and go straight into your processing and not think about anything else. Um, PPK, obviously, you need to combine it, but we do get some, we'll talk about in a few slides, sometimes where you don't have to do an extra step.
One thing I want to mention, Matt, before you go on, just in case anybody out there is a little confused in seeing this mission plan screen versus the other screenshot you had of a different controller, it's important to know. So, Inspired Flight on our IF800 aircraft, there are two configurations of the system. But this controller, the difference really being the controller system. This is our HureLink configuration. It's our entry level offering that is fully US made, but does not meet the Blue UAS, Green UAS, NDA compliant rules, but still totally usable for a majority of commercial customers. And the other screen that Matt was showing was our GS1 controller, our premium Blue UAS system that admittedly is a much better user experience and offers a lot of capability in addition to its compliance. But I think it's really important to note that as it relates to all the workflows we're discussing today, all the features regarding the saving of multiple intrip profiles, how you can see the icons, workflows are identical across the two controllers. There's no difference in how these systems would work. The only major capability advantage for an RTK workflow that the other controller, the GS1, might offer over this system is that
I'm back.
it has the ability to connect to the cellular network.
All right. Sorry about that. My Zoom crashed. All right. We
Oh, good.
good?
I filled up some time for you. Yeah, we're good.
I like vamping. Okay. All right. So as I was alluding to, software, right? So step one is get the hardware. Step two, use the hardware. Step three, process the data that comes off that hardware. So photogrammetry processing software, none of the Sentera camera data is proprietary. It does not require Sentera stitching. It doesn't require you to use a specific processing engine. You can, anything that will ingest our imagery and stitch it, we're happy with that. So, and if you don't see your favorite flavor of stitching software on here, please reach out, let us know. But the big ones are your Metashape, your Pix4D, what have you. So, 65R data is, just regular off-the-shelf RGB data. We publish all of our geotags. We follow all of the geotagging standards. And so you really should be able to pump it into almost anything that will accept that sort of imagery and get a map out of it. So that's really cool. Field Agent obviously is a Sentera product. It's a data management project. It's a great bang for your buck for all this sort of stuff. But Metashape, Pix4D, great options for your RTK and all of that, and your post-processed PPK imagery. So let's talk about PPK processing itself. So we have partnered with a couple companies to make sure that we offered solutions here. So Trimble Business Center, we are looking at the Trimble Dimension 26 as a release for compatibility with the data from these systems into TBC. Propeller Arrow, and we're going to actually show some of the propeller workflow here in the next couple slides, which is really cool. It's been really beneficial with this system. Emerald Studio works as a free option for PPK post-processing of 65R imagery with our files, or converting any of your files that come off the camera into Rhinex files if you need that for a different flavor. And then we have also partnered with RedCatch to offer a post-processing solution that's actually really nice. That is like a $70 to $100 a year license, and it gives you this really awesome like user interface to go and PPK tag all your imagery and sort it. It's very nice, and it even will give you the option to set up some projects in like a Metashape or a Pix4D. So that one's really cool, really affordable. But we process or we we partner with these companies to bring you a solution to use your PPK data. So in Propeller, this is really cool. So instead of using a traditional base station or what have you, if any of you are familiar with Propeller, they make a product called arrow points. And so they are these GCPs that have GPSs inside of them. And so what you do is you go put these GCPs out, and you really only need a handful. I won't speak for what Propeller's actual specifications are, but they sent me 5, and that's what I've been using and having tremendous results. So you can see in this field on the right-hand side here, we've got 5 GCPs. And what we did is we went and flew and we uploaded all of our files into Propeller's software platform. So this is our trigger file, our rover file, all of our images. And then we tied that survey to those GCPs because those are smart GCPs. They are logging all of this data and they upload up into the cloud with where they were, how long they were there for. And so we tie those together. Then it uses publicly available corrections network or their Propeller corrections network to go and essentially PPK process both of these things. It will go process the flight data and it'll process the arrow point data. And then what it does is when it processes, so then it's going to take all of that and it's going to make the map and it's going to auto detect where all those GCPs are because one, they know where they are in the imagery and then they know where they are from all of the logging that they did. It auto detects, puts those manual type or those tie points in there. And so what you end up with the deliverable is this super high accuracy map, and you didn't have to really do any extra steps. You didn't have to go do the PPK processing yourself. You didn't have to go find and put in all that GCP information yourself. It was just all collected at the time of flight, uploaded, and then all of the processing was handled by Propeller automatically. And so what you see down here is the actual error report that came back from this flight. And so this is showing a total error of about 2.3 centimeters, and that's with your GCP tie-ins. So that's like a global accurate, everything in that map is going to be accurate to 2.3 centimeters from the global reference frame, which is really cool. So we made this ortho, and that's pretty cool. But then what we did with that ortho is then we generated an elevation map and some contour lines. So this shows the field has a pretty nice big hump in the middle. We've got about 10 feet of elevation change sort of between that yellow region and the outside of the yellow region and the outside of the green region before it gets down into the blue where there's more sloping. So this is really cool, but then even in Propeller, you can do extra cool stuff. In particular, in agricultural fields, especially before planting season and all of this, right? We really care about where does all that runoff go? Where does the drainage go? How do we plan for this? How do we make sure it doesn't affect our crops? And this is applicable not just to agriculture. This is applicable to pretty much anything where you're moving dirt around. And they've got a watershed analysis in there. And so with all that data that we were put in there, we were able to simulate this watershed and you could see where all the drainage was going to go. And it lines up really well with the existing drainage that does exist for this field. So it was a nice validation of, was this done correctly? So on the other side of this, so that was an automated process in Propeller. I wanted to show some of the red catch stuff and also show a feature that I haven't really seen anywhere else much around the industry. So we are looking at some RGB imagery right now, but this was a PPK flight from an IF1200 and a 6X multispectral sensor. So this is multispectral PPK processing, which is really not a widely available offering, especially on a science grade multispectral like 6X. So this is sort of the only way you can do this if you want that sort of data with a multispectral camera. So this is pretty easy. You import your imagery files, you import your timestamp, you import your rover file, you upload your base station files, and then really you hit run and generate, and it's going to go and it's going to process like here's the solution for the GNSS or the GPS high accuracy solution. It's going to go retag those photos for you. You actually get the option to retag the original photos, or you can just get a copy. Personally, I take a copy every time. And then what I did once I processed all of that imagery and I processed all the bands for that, I dumped it into Field Agent. And so in Field Agent, we've got this nifty little EXIF and XMP viewer in here. And so we could see with the updated geotags that after we did the PPK processing that we were able to get a GPS XY accuracy of about 6 millimeters and a Z accuracy of about 1.7 centimeters. So we had these really high accuracy geotags. And then we stitched the data together. And so what we see on the right there is the RGB. So just your regular, visual color photogrammetry. Then we had this nice DSM that came from that, which is really cool. 6x's RGB is a rolling shutter, so sometimes you're used to the bowling or the dome effect, but the RTK and the PPK solution really helps flatten all of that out, and so you get these nice DSMs. And this is over just a small baseball field that we fly. But then finally, we have a PPK post-processed NDVI map. Now, granted, this is Minnesota in, March, so we had sort of a nice day, but you can see where we had. Oh, I pushed the wrong buttons, guys. Whoops. Uh, so you can see the sand and the snow, very dead. Some of the grass out there, much more alive than the dead sand and snow. But it's really cool. It's a very cool use case of how we can use all of this technology and the kind of data we can generate from it. Okay, we've talked about a lot of different workflows. We've talked about a lot of different data. How do you know which one you should use, which workflow you should use, how you should set all this stuff up? We thought of that and we put it all together so it would be nice and easy for you to find. So when you get
And if
your
you
art,
happen to forget the immense amount of information we've thrown at you during this webinar, we're going to show you where to go get it.
yes, 100%. So out on our support site, you can select the RTK PPK module, and one of the very first things you'll see on the left-hand side there is the which workflow should I use link, and that will bring you out to this little, we'll call it a form, but really it's a bunch of drop-down boxes. So you're going to select your operation type. This would be like RTK or PPK. Accuracy type. Do you want global or relative? Where are you going to get your correction source from? All that sort of stuff. Asks you like 4 or 5 questions. You hit submit, and what that does is then it brings you straight to the standard operating procedure for those exact options that you've selected, which is great. And then within that standard operating procedure, there's links to anything else you could possibly need to figure out that, like, how do I use this? But it's literally step by step. If you're going to fly with these settings for your data collection or these parameters that you need to hit, then bam, it's going to bring you right exactly to that workflow. All right, and I'll let Adam talk again.
Yeah, just in terms of support, one of the really important parts of bringing such a complex product to market was making sure that we have the documentation really to back that up. So available both through Inspired Flight's kind of GitHub support center as well as Sentera's is just incredible amount of information on exactly how to use the system, example data sets, and again, like the recommendations on processing tools and things of that nature, all the way down to one of my favorite tools that Sentera offers for the 65R is a mission calculator where you input effectively work backwards. If you're targeting a GSD with an app, you just select IF800 with 65R, and they'll tell you exactly how much coverage you're going to get for your target GSD, or if you're limited to an altitude, what type of GSD you'd be able to get. So a lot of really cool support and documentation steps to hopefully avoid all the customers out in the field, all the people that are kind of out on the sides of roads or fields trying to do work, from having to get in touch with support from DroneNerds, your local dealer, Inspired Flight. Of course, we're going to be here to support you guys. Training support is one of the most important things to Inspired Flight and Sentera. And I think if you kind of survey the industry, you'd hear similar things about both of our companies' accessibility, but really wanted to ensure that all the documentation for all the various workflows for how you would connect a Trimble R980, step-by-step instruction for how to link that up. So we're not delivering to you effectively a science experiment. Again, going back to what I said at the beginning, this is a tool meant for you to bring into the field and build maps in whatever way you might need to. Yeah, and with that, look forward to answering some questions.
Hey, thank you so much, guys. So yeah, really amazing how fast and accurate this setup is with IF and Sentera. So yeah, some really amazing technology. So starting out with the first question, is Inspired Flight planning on developing a similar workflow as the DJI Enterprise app, specifically the linear mission function? It's been a crucial tool for this person, and they don't see it with NDAA drones.
That is a question I do not have an answer for. So I'd be happy to, if anybody wanted, whoever asked that question, ping me LinkedIn, adam@inspiredflight.com. Happy to go track that down. We're constantly We're pretty much on a quarterly basis at this point for pushing out updates to the Inspired Flight ground control ecosystem. We're always introducing new features, new mission profiles, new capabilities to make your missions easier. So don't know exactly if that is on our current roadmap, but maybe it could be.
And the next question, I know you mentioned the software is not proprietary, but just to confirm, this person is asking, what's the compatibility or integration with Drone Deploy, and what other mapping 3D applications can be used?
Yeah, we're happy to work with Drone Deploy. We've had a relationship with them for a while. They seem to be very focused on, small platforms, but if you go to them and say, "Hey, we want this Sentera data inside of there," I'm sure there would be no problem getting ourselves like hooked up with each other and doing that sort of thing, assuming you're talking about the data processing.
Yeah, Inspired Flight drones are not currently supported within Drone Deploy from a like an operational perspective. Something we're working on, but we're pushing on our side. If you'd like to push from yours, that'll only help.
And next question, so this person just says L1 and L2 frequencies only, any L5?
Ah, yes. So this is a good question. So it is a ZF9P inside of the RTK PPK module. This is sort of the industry standard for a lot of these enterprise level aircraft and their GNSS systems. So ZF9Ps only come in a couple flavors, and they support either L1, L5 or L1, L2. They don't support L1, L2, L5 or full spectrum. We will see this with the advent of the X20P as that comes to market from U-Blocks into fruition. So in the future, very likely to see another version of this module that would have an X20P in it with full spectrum. But right now, it was either L1, L2, or L1, L5, and the L5 bands just aren't as active as the L1 and L2 are in their current state.
And also, next question is the RTK attachment option only available with the Sentera camera, or is it also available with the Sony LR1?
Yeah, great question. The answer is today this module is only compatible with the Sentera 65R and 6X cameras. It is absolutely on our roadmap to bring compatibility to Sony RLR1 as well as other cameras that we offer. But the strong focus for Inspired Flight is with Sentera and where we see these cameras being kind of more enterprise grade, especially. So I do expect that RTK support will come online with Sony LR1. I can't commit to a timeline right here. But as of today, yes, that attachment is only compatible with Sentera products.
And any like a base station compatibility?
I haven't been down the rabbit hole on that one yet, but if it has a USB out and it supports RTCM3 messages and can log Rhinex, then I have no doubt in my mind. So this is a great one. Similar to what Adam said, like if you've got interest in this or you have a Leica base station, right? I mean, the big thing with compatibility is like one, understanding which model people are looking for, and then two, getting my hands on one of these models. So find me on LinkedIn or matt.skelton@sentera.com. Shoot me an email, and happy to help figure that out.
And any luck processing through DJI Terra?
You can process 65R data through Terra, um, to the best of my knowledge. The last time I saw it done was probably a year ago. I don't think that they have shut out 65R data, so you should be able to put that in there. All of the camera parameters that you need are published on the support site for 65R. I've had some really cool processing in there the last time I did it. So I don't expect it to not work. 6X data will not work through Terra. We have been locked out of that.
And the next person just wanted to see if they heard things correctly. Is the Sentera a rolling shutter?
Yes and no. You heard that correctly. Only the RGB sensor on the 6X multispectral sensors is rolling shutter. The 65R, the 65 megapixel global shutter, that one is a global shutter. And so all of the other imagers on a 6X, the multispectral, all of the monochromes, those are global shutter, as well as the thermal. But the RGB sensor, the 12 megapixel, or sorry, the 20 megapixel RGB sensor on the 6X multispectral sensors, that one is a rolling shutter.
And the next question, can I plan flights for import in UGCS?
Absolutely, is the short answer to that. Very good relationship with SPH Engineering and people that make UGCS. There is a kind of a bit of a workflow on how you plan your missions in UGCS and then get that onto the controller because there is not a UGCS Android app that can work directly off our controller. So you are able to capture all the complexity and everything you can do in UGCS, and then you would upload that onto the controller and fly the mission through inspired ground control, but you maintain all the complexities and all the added advantages of being able to plan in UGCS.
And is obstacle avoidance coming in the near future for inspired flight drones?
Well, I guess it depends on what you define as near future. I would say you're unlikely to see it from inspired flight in the next 6 months, if that's what near future might mean for you. But I wouldn't. I would expect us to continue to up our game as the next 18 months roll by.
And how do payload, weight, flight speed, and environmental factors like wind influence real-world endurance on the IF800? And how should operators account for that when planning mapping missions with the 65R?
I think that's a great question. I mean, of course, high wind environments, your direction of flight, if you're flying into a massive headwind throughout the whole, like all those variables will affect your mission planning. In reality, the with the 65R in completely pristine at sea level, no wind conditions, with a still a safe reserve on the aircraft, we're getting 42 minutes of flight time. So that's why you kind of see us using like 40 minutes as a gauge, accounting for some wind environments, a higher altitude. Generally, unless you're starting to operate seriously high altitudes, does the flight speed get affected by wind more than really like 10 to 15%? I don't know, Matt, you're in the field constantly with these things. Do you see that differently?
Yeah, I mean, so your largest environmental factors is really not going to be so much the weight of our payloads, but it's the temperature outside and the wind. Those are the two that I paid the most attention to. So temperature outside, when it gets a lot hotter, the air becomes a lot thinner. Motors and propellers have to work harder. You're going to lose some flight time that way. And conversely, in the cold, your batteries become less efficient. Your air is much thicker. Everything's much draggier. So when you're in extreme conditions, which I unfortunately get to experience here in Minnesota, in the summer I'll be flying in 90-degree F, and in the winter I'll be flying in 20-degree F. So you have a pretty big, a 70-degree swing there. But anytime you're sort of in that like 50 or maybe even like 45 F to, I don't know, let's call it like 75 F, there is not a huge amount of endurance change that I've seen considering, because temperature, air density, how the thing actually flies. So then wind becomes the next big proponent of it. If it's anything around like a 10 to a 12 mile an hour wind, I take almost zero consideration. When we start to get 15 sort of the median one, and then when you start to get a 20 and above, that's when I start to consider, okay, one, should I even be flying because the gusts are going to be high? But two, yeah, if I'm flying into a headwind. When you do have, strong sustained winds, what you can always do is you can fly crosswind, and that sort of helps mitigate just head-on or a headwind or a tailwind, which is a little bit better for aerodynamic efficiency, especially if you're turning into the wind. That's like some very like fixed wing stuff, but it does apply to multi-rotor as well. So things like that. But at the same time, if you're flying a really long, skinny field, right, with a headwind and a tailwind, I would still take flying into and out of the wind with the long, skinny field rather than flying the short way across the skinny field and sneaking up. That would be really inefficient.
That person got more than they were looking for. I think we answered it.
Oh, yeah, very thorough. So next question is just a clarification from one of the earlier questions. The person says, to clarify, can we connect to cores with a GS1 control without the PPK?
I think they're asking if you didn't have the module and you connected to cores, would you still get RTK corrections?
It's kind of how I'm reading that, without the PPK module.
Right.
The answer is no.
Uh,
For injecting RTK or correction data to the imagery. You there are ways and new features coming out for Inspired Flight to connect to Core's network to enable RTK for the aircraft to fly from like in navigationally with RTK. But that is not really what we're talking about here, focusing on getting correction data to the imagery itself. That does require the use of this module.
All right. And is terrain follow an option for inspired flight?
Yes, it is. You can whether you're using existing map data from Google Earth, Bing, that you want to do passive terrain following over, or uploading your own custom digital elevation model is also possible. You can do active terrain following using kind of a laser altimeter that's available on the IF800, but that's going to be for much lower flight applications like geophysical applications versus a traditional photogrammetry workflow. So using passive terrain information, yes, the Inspired Flight aircraft can do terrain follow.
And how do you typically estimate battery requirements and mission segmentation to avoid incomplete data sets or unnecessary relaunches?
I think using the mission calculator is going to be one of the best ways to do that. Not like really just in your pre-flight planning, just really understanding how big of an area are you looking to map, and then working backwards from the GSD require in using, even if you want to be very conservative, a 35 or so minute flight time in the Sentera mission calculator, you'll be able to get a really good sense, or when you're just planning the mission on the screen, you'll be able to get a really good sense of how deep into some area you'll be able to go on one battery pack, and then make some logical decisions on rally points or when to do battery swaps, things of that nature.
And does the IF800 support LiDAR sensors?
Yep, absolutely. The majority of LiDAR sensors are field swappable with the 65R toollessly. There's a pretty nifty rail system on the bottom of the IF800 that allows you to adjust centers of gravities of payloads and go between a much heavier LiDAR payload and a much lighter Sentera payload without requiring the use of any tools. Pretty much any LiDAR under 3 kilograms, which increasingly is becoming the majority of them. I kind of tend to use my rule of thumb is if the LiDAR costs sub $100,000, odds are high you can go on the IF800. If they're in excess of $100,000, it's likely too big and requires our IF1200 aircraft.
And any parachute capability?
No, and I'll leave it there.
Okay. And next person, apologies if I missed it, but is there capability to fly with two sensors, um, maybe a 6X plus the 65R, both mounted on the IF drone to get both high resolution RGB and multispectral data from the same flight?
Short answer is not easily. What's become really common for us is, especially with our IF1200 aircraft, a lot of customers are using LiDAR co-mounted at the same time with either the 6X or the 65R camera. And you're able to collect LiDAR data and camera data in one flight. But there is a constraint on the system now where we cannot support two separate gimbaled payloads. We're only able to support one gimbaled payload today.
On paper, there are ways that this could be done. We could operate a camera in a standalone mode, but it would be a pretty custom solution. It would not be a productized solution.
And the last question, are the IF controllers NDAA compliant?
So Inspired Flight offers two controllers. The GS1 system, which is the one that looks very similar to like an RC Plus, if you're familiar with it, the more premium looking controller from Inspired Flight is absolutely NDA compliant. Our other entry level offering based off the Blue Here link is not NDA compliant. It is fully US made and satisfies requirements for many customers, but is not technically NDA compliant.
Well, thanks so much, guys. And if you do happen to have any other questions, you can always email us at experts@dronenerds.com. But thanks again to Adam and Matt for joining us today, and hope everyone has a great day.
Thanks, everyone.